In this lecture, we will look at requirements modeling. In the system analysis phase, you should understand the proposed project, ensure that it supports business requirements, and build a solid foundation for system development. You will do requirements modeling, data and process modeling, object modeling, and development strategies. In requirements modeling, you will do fact-finding to describe the current system. You will also define the requirements for the new system. In data and process modeling, you will look to graphically represent the system using data and processes. In object modeling, you will create objects to represent things, transactions, and events. Development strategies looks at software trends, development alternatives, and the potential for outsourcing. A system analysis needs to have strong analytical skills and interpersonal skills. Team-based techniques can be used, such as JAD, RAD, and Agile methods. The object is to deliver the best possible system at the lowest possible cost in the shortest possible time. Joint application development brings users into the design process. Rapid application development uses a condensed version of the system development life cycle. And Agile method stress intense interaction between developers and users. In joint application development, it brings users into the development process as active participants. The user's involvement can either be formally or informally created to successful system. It's always good to have the user involvement. This helps to ensure that the system has everything that the user needs to be successful. JAD participant and roles. You have a project leader and one or more members. Participants are insulated from distractions of day-to-day operations. Some disadvantages of JAD is more expensive than traditional method, and it can be cumbersome if the group is too large. Some advantages to using JAD is JAD allows key users to participate effectively. Users are more likely to feel a sense of ownership, and it produces a more accurate statement of system requirements. When you're using rapid application development, it uses a group approach like JAD. JAD produces a requirements modeling, and RAD produces a new system. You have a complete methodology, a 4-phase life cycle that parallels the traditional software development life cycle. It reduces cost and development time, it increases the probability of success, and it relies on prototyping and users' involvement. Prototypes are modified based on users' input. In requirements planning, teams agree on business needs, project scope, constraints, system requirements, management authorization to continue is obtained. User design. The users interact with analysts to develop models and prototypes. A combination of JAD and case tools are used. Users understand, modify, and approve a working model. Some objectives to RAD is you want to cut the development time expenses by involving the users in every phase of the system development. You want to allow the development team to make necessary modifications quickly as the design evolves. Some advantages is systems are developed more effectively, quickly, with significant cost savings. Some disadvantages is it does not emphasize strategic business needs, and the system might work well in short term but miss long-term objectives. And it's less time to develop quality, consistency, and design standards. Agile methods attempt to develop a system incrementally by building a series of prototypes and constantly adjusting them to users' requirements. Developers revive, extend, and merge early versions into the final product. It emphasizes continuous feedback, and each incremental step is affected by what was learned in the prior steps. Agile supports various modeling tools such as unified modeling language, use cases, business processing, among others. With Agile, you have a Scrum. A rugby term, pigs include the product owner, the facilitator, and the development team. Chickens inside users, other stakeholders, and managers. Scrum sessions have specific guidelines that emphasize time blocks, interaction, and team-based activities that result in a deliverable software. There's advantages and disadvantages to using Agile. It's very flexible and efficient in dealing with change. Frequent deliverables constantly validate the project and reduce risk. Team members need a high level of technical and interpersonal skills, and it may be subject to significant change in scope. Modeling tools and techniques involves graphical methods and non-technical language that represent the system at various stages of development. It can use various tools. You have a functional disposition diagram, modeling business functions and show how they are organized into two-level processes. When you look at a functional disposition diagram, you have top-down representation of a function or process, similar to an organization chart. A data flow diagram shows how the system stores, processes, and transforms data. You have additional levels of information and detail are depicted in other related data flow diagrams. A use case diagram shows the interaction between the users and the system. Then you have a sequence diagram. This shows the timing of interaction between objects as they occur. When you look at future growth, costs, and benefits, you have to look at scalability. The system ability to handle increased business volume and transactions in the future. A scalable system offers a better return on initial investment. To evaluate scalability, you need information about project future volume for all input, outputs, and processes. You have to look at the total cost of ownership. It is especially important if the development team is evaluating several alternatives. One problem is that cost estimates tend to understate indirect costs and rapid economic justification. When you're doing a project, you have to do fact-finding. First, you must identify the information you need, develop a fact-finding plan. You have to look at who, what, where, when, how, and why. You have to look at the difference between asking what is being done and what could or should be done. Typical questions to ask is, the business functions are supported by the current user? What strategic objective and business requirements must be supported by the new system? What are the benefits and total cost of ownership of the proposed system? What transaction will the system process? What information do users and managers need from the system? Must the new system interface with legacy systems? You also ask, what procedures could be eliminated by business process reengineering? What security issues exist? What risks are acceptable? What budget and timetable constraints will affect the system development? When you look at the who, what, where, when, how, and why, who performs each of the procedures within the system? Why are the correct people performing the activity? Could other people perform the task more effectively? What is being done? What procedures are being followed? Why is that process necessary? Often procedures are followed for many years and no one knows why. You should question why a procedure is being used at all. Where are operations being performed? Why? Where could they be performed? Could they be performed more effectively elsewhere? When is a procedure performed? Why is it being performed at this time? Is this the best time? How is a procedure performed? Why is it performed in that manner? Could it be performed better, more effectively, or less expensively in some manner? This just shows that there's certain questions that you should ask about the current system and some questions that you should be asking to determine the proposed system. The Zachman framework for enterprise architect helps managers and users understand the model and ensures that overall business goals translate into successful IT projects. Sometimes you might conduct interviews. You need to determine who are the right people to interview. What are the objectives of the interview? Develop questions, prepare for the interview, conduct the interview, and then document the interview and evaluate the interview. Other fact-finding techniques is document review. You should review old and current forms and documentation. Observation. Seeing the system in action gives you additional perspective and a better understanding of the system process. Plan your observation in advance. Consider the Hawthorne effect study. Productivity seems to improve whenever workers knew that they were being observed. So sometimes it's best to not let the users know that they are actually being observed. That way you can see how they are using the system real time. Questionnaires and surveys. When designing a questionnaire, the most important rule of all is to make sure that your questions collect the right data in the form that you can use to further your fact-finding. Use fill-in forms. Sampling. You could have systematic samples. Select every 10th customer for review. Stratified sample. Select 5 customers from each of 4 postal codes, random, any 20 customers. Main objective of a sample is to ensure that it represents the overall population accurately. And you can also do researching using the internet, information technology magazines, book, obtain background information, technical material, and news about the industry, trends, and development. You could also do site visits. Then you have to look at what is the difference between interviews and questionnaires. Interviews is more familiar and personal. Questionnaires give many people the opportunity to provide input and suggestion. You have brainstorming, structured brainstorming, and then unstructured brainstorming.